Alrighty guys, today we're going to be talking about solving systems of equations. So the first thing I want to quickly review are the methods we have to solve systems. We have elimination, substitution, and graphically. Please remember, elimination and substitution are the only ones that satisfy algebraic calculations, right? Because we have to do algebraic manipulations to find our answers. Whereas graphically, even though we do solve for y to plug it in our calculators, is a little more of a visual solution. All right, so we are going to review all three of these for all different types of equations, starting with elimination. Now, I typically use elimination really only for linear systems, okay? Remember, the key to elimination is to eliminate one of our variables. All right, so in this case, we have an x variable and a y variable. We're going to choose one to eliminate and use some multiplication to help us do that. So, something that I need to have in order to eliminate a variable are coefficients that are opposites, okay, meaning opposite signs, and the same value. Okay, so they have to be the same number, but with opposite signs. So I'm going to look at the y value here because it already has the opposite signs, okay? If you need to change a sign, remember, you can always just multiply by a negative number. Now, how do I make a 5 and a 7 look the same? Well, one trick with elimination that I tend to use is right, whatever that coefficient that I'm trying to cancel out, as the value I'm multiplying the opposite equation by. So I'm going to multiply the first one by 7 and the second one by 5, just to make sure that I get a number that will be the same. All right, so when I do that, I get 28x plus 35y equals 42. And for the second equation, I have 30x minus 35y is equal to minus 100. So now, as long as we see one of our variables, like we do in this case, having coefficients that are the same but different signs, we know that they will cancel out. What gets brought down is the sum of the first two, which will be a 58x, and the sum of the values on the other side, which is actually a negative 58. So to solve this, I actually have to divide out by 58, and we're lucky. It cancels out nicely to get an x value of negative 1. Now, remember, solving systems of equations is always going to be an ordered pair, meaning that for every x value, we need a corresponding y value to have a complete answer. So we're going to take this x equal to negative 1 and plug it into one of our equations. It does not matter which one. I tend to use the one with the least amount of negatives. All right, but as long as we plug it in correctly, we should be able to solve for our other variables. So what do we get for our y value? Well, I'm going to add 4. Divide by 5, and I get y is equal to 2. So what's my answer to this question? Well, it is the ordered pair, x equal to negative 1, y equal to 2. All right, so it does become a coordinate. Now, with systems of linear equations, we really only have two options. We either have no solution, or three options: no solution, one solution, or infinitely many solutions. All right, it will be no solutions if we end up going through elimination and getting a false statement. It will be infinitely many solutions if you go through the process of elimination and end up with a true statement. So just keep your eyes peeled for those. Now, we could also use substitution on systems of linear equations. Now, I tend to only use substitution on systems of linear equation when one of the variables does not have a coefficient. And the reason I do that is to avoid fractions. Now, because x has no coefficients, I'm actually going to use this equation to isolate my variable. And the reason that I want to do that is because I want to make a substitution to turn this first equation into an equation no longer in two variables, but rather an equation in one variable. So I'm going to substitute this entire expression in for my x value. So 2 times x, which is minus 2y plus 5, plus 3y is equal to 6. So I'm going to continue solving. I'm going to subtract 10, and I'm also going to combine like terms in the same step. So I'm going to get negative y is equal to negative 4, divide both sides by negative 1, and I get y is equal to 4. Now remember, every solution needs to be an ordered pair. So I need an x value. So I'm going to plug it in here, which is already solved for x, to find my corresponding value. So that's minus 8 plus 5. X is equal to minus 3. So my ordered pair for this one is minus 3, comma 4. Okay, so now what about non-linear systems of equations? What happens when I have, in this case, a parabola, because we see the x squared, and in this case, a line, because we see x to the first power? Well, what I would do is I would use substitution for this. Okay, and typically I'm going to solve this first equation for y so that I have a nice, easy substitution. Okay, but you can substitute for either variable as long as it is a nice sentence. But remember, if you have a parabola and you start plugging things in for x, you will have to square them appropriately. So I highly recommend solving for y. All right, so I'm going to do that with my linear equation. Minus y is equal to minus x minus 1, divide by a minus 1. I get y is equal to x plus 1. So now we have y equals and y equals. We want those to be the same y's. So I'm making a substitution of x plus 1 in for this y. So x plus 1 is equal to minus x squared plus 3. Now this has turned into a quadratic. So we're going to have to use those methods of quadratics. Now remember, when we have a system of a parabola and a line, we have 3 options. We have either 0 solutions, meaning the graphs do not touch at all. We have 1 solution where they only intersect at 1 point, or 2 solutions where we intersect at 2 points. Many of them will have 2 solutions. All right, so how do we solve this? I'm going to move this over to this side and this over to this side, because with quadratics, I like to make sure that I'm set equal to 0, either to use the quadratic formula or to factor. In this case, I'm going to factor. 2 numbers that multiply to negative 2 and add to a positive 1 is plus 2 minus 1. And we get 2 x values here. We get x is equal to minus 2 and x is equal to positive 1. Now remember, for every ordered pair, we need an x and a y value. So we have 2 x values here, which means we have 2 solutions, but these solutions need a corresponding y value. So I plug this x value into this y equals x plus 1, which is negative 1, and I plug this y is equal to 1 plus 1, which is 2. So what are my ordered pairs here? Well, we have x is equal to negative 2, y negative 1, and x is equal to 1 comma 2. So we have 2 solutions, and there are these 2 ordered pairs. Okay, so now what about graphically? Let's see if we remember how to solve graphically. Anytime we have a system of equations, notice I already have it here, the solutions are going to be the points of intersection. Okay, so graphically, we want to make sure we're able to solve for the points of intersection. So now, I'm not going to go over this with the calculator because I've talked about this in other videos before. If we have 2 equations, right, and they both are able to be solved for y equals, right, we can plug those 2 equations into our graphing calculators to look for the points of intersection. And how do we find them? Well, once we see the graph, we're going to press second trace to get the calc menu and choose option number 5, intersect. All right. The cursor has to move. And remember, since this is a quadratic linear and we have two solutions, you will have to do this 2 different times, okay? Repeat these steps 2 different times. But at the bottom of your screen, you should see what your solutions will be. So this is just a quick refresher for finding the solutions graphically if we have equations. In many cases, we are actually going to be given a picture right there. And we're going to be asked to identify the solution to the systems of equations. So now we have a quadratic, we have a line. We see that we have 2 different solutions. So what are those solutions? Well, they are the ordered pairs that are at the point of intersection. So that is -2 minus 3 for that first ordered pair. And 1, 2, +2, 1, 2, 3, 4, 5, comma 5. All right, so those are our 2 points of intersection. Those are our solutions. But every once in a while, and it may not come up on your final, but it definitely is something that appears frequently, is you'll see this, f of x equal to g of x. What happens when one function is equivalent to another function? Well, the key for this type of question is that it typically only wants the solutions that are x values, all right? They don't really worry about what the corresponding y value is. They want to know what is the x value that makes this true, okay? And that's only when you see a function notation equal to another function notation. So if we look at this graph, we see looks like an absolute value and some other kind of weird function. There are 2 points of intersection here, 1, 2, 3. So that's a -3, 1, 2, 3, 4, comma 4, and a 1, comma 3. What are they looking for in the answer key? Well, they're looking for you to state all the values of x where this is true. Well, that's going to be -3 and 1. Okay,